Good morning. This video is scheduled for Wednesday, so happy Wednesday. And today what we're going to be doing is just kind of reviewing how we name acid and bases. Now remember, bases, we just follow our normal ionic rules. But thinking back to Unit 5, when we learned nomenclature, remember acid naming is a bit tricky. It depends on whether the acid is a binary acid or a ternary acid. So I might take a couple of minutes here just to kind of go over and read through these rules. And what I'm going to do is go ahead and start on kind of the naming practice. So with naming, we'd start HI. We recognize it's an acid because it starts with H. And then we recognize that it's a binary acid because it's just two elements. So I know with my, that is not what I want to do. With my binary acids, they always get the prefix hydro. So I start with hydro. And then I know I changed the ending of the element to be IC. So iodine would become iodic. So we would call this guy hydroiodic. And I'm going to squeeze acid in there. Number 2. Again, it's an acid. Starts with hydrogen. But this guy is a ternary acid. It's hydrogen with a polyatomic ion. So I would, ask myself, what is the ending of this polyatomic ion? Well, that is chlorate. So I know, scrolling up to my rules here, if it ends in 8, I change the ending to IC. Now there's no prefix hydro, so it would just be chlorate changing to chloric, and then I would add the word acid. So just chloric acid. Number 3, PbOH4. Okay, I see that hydroxide ion, I think ionic. So I just am going to name the metal, stays the same. Then I throw hydroxide in there. But then I realize that lead is one of those pesky special metals that needs a Roman numeral. And in this case, the Roman numeral would be 4. Hydroxide's -1. There's 4 of them, so altogether that's a 4-. So we know lead has to be +4 to cancel that out. And then one more, H2SO3, ternary acid, hydrogen and a polyatomic ion. So I think to myself, okay, what's my name for SO3? Oh, that's sulfite. So I know if my polyatomic ion ends in ITE, I change the ending to OUS. So that would be sulfurous acid. I'm not going to do much with formulas here. What we should remember is that we want to do our swap and drop. So just real quick with percarbonic acid, that would be percarbonate. So that would be H+. Hydrogen, I know, always has a charge of +1. And then my formula for percarbonic, well, carbonate is CO3. Per or pair means there's one more oxygen. And then because my charges don't balance, I swap and drop to get H2CO4. I guess I could do one more. Chlorus. So I know that's chlorite. So that's H+. Let's see, chlorate is ClO3. So ite means it's one less oxygen. It would be ClO2. And in this case, my charges cancel out. So it would be HClO2 as my formula for chlorous acid. Now, there's plenty of more good examples on there. So if you want more examples, you can always just Google search for acid and base naming, or you could always try to meet during our office between 12 and 2.